ahead and maybe start your presentation.
Okay. Let me share my screen.
Yeah, please go ahead.
Let me just switch this.
Hello, Quest.
Okay. The system that I made consists of this tech stack that I use, but it's so heavy that my system itself cannot take the actual thing. But I made it work in just in time. So I made a paper about it, and I called it the robust evaluation of machine learning models for a financial risk evaluation systems. So the tech stack that I used was Streamlit for front end, and then Pandas, NumPy for numerical computing. And then I use scikit-learn, ARC models, stats models, and Torch for machine learning and deep learning. So now I'll be starting to read a little bit about the background. So I will just do some summary so that we can get on with the application and show you the front end. So for now, the financial markets have been affected by information inefficiencies, so which can lead to unfair advantage to some of the most powerful competitors like BlackRock, Citadel, and so on. So the study and the project itself aims to explore the financial market behavior using machine learning techniques that to reduce informational inefficiencies in the markets. So the keywords that I highlighted is LE5 for interpretability, and then statistical testing and data science, machine learning, and finance. Okay, so the scope of the project only focuses on the machine learning framework that I use, and then the work only includes the S&P 500 and the Dow Jones Industrial as the data set since I the Alpaca API was not responding on the technical time frame. So and finally, the whole system incorporates robustness and causal style modeling comparison to establish strict causal relationships in the financial market. Okay. So for the methodology that I use the ETL protocol, the extract transform load, which transforms raw noisy market data into reliable information, which was based in 1892 to 2026. And then when I cleaned it, I only used the 1999 to 2026. And for the my causal assumption for the whole data set is that for if the volume is high, then the closing price the should be really high, and then which derives the return to be high or low depending on the actual principle of the user, and which shows that certain time span influences the potential closing values of the specific time. So for the data pre-processing, I use the S&P 500 and Dow Jones Industrial, which I imputed and cleaned, and with the potential for feature and data visualization. And then I also did some feature engineering and explored data analysis alongside with it, which I use Sarimax. And then I derived the residuals of the Sarimax and then feeded it into a GARCH model, which I then use the conditional volatility of it for extra features. And
Okay.
then I also feature engineered the binary classifier or the target variables, which zero and false values, which determines the price going up or going down. So for the modeling base, I use the base models, the logistic regression, support vector classifier, and of course classifier, and some of the state-of-the-art models like CatBoost XGBoost, and library inputs and classify. And then I assembled it using stacking classifier and um, out of or not a very rare method called geometric ensembling, which penalizes model disagreements. And my thinking for this is the no free lunch theorem, which states that no model is universally superior over the other, and may some cases may perform on various tasks over the other. So in order to confirm this, do statistical testing and stress testing with alongside impossibility alongside with it, which states that in order to see if the model is doubly robust, we can do applied model assumptions with the significance of features and stability of its frequencies. I use McNemar's test, double Mariano's test, Wilcoxon sign rank test, and for numerical values, I use performance gap, Friedman, and alongside with that Friedman test, Nemanitoso test, and bootstrap confidence intervals, and then Kendall's W to measure the agreement between the small ones. And recent foremost, I use LE5 for model interpretability, but I use the A/B tested values for it since I was lacking in the technical time frame because I need to deploy the model. Okay, for the results of the actual model and project, the LSTM performed surprisingly low, which was 45 and 46 in AUC, which was surprising because it was already in the research back sequence, which was 20, 10 and 20. And then alongside with that is the classical ensemble methods, which was again XGBoost performed and light gradient boosting model performed highest. And the statistical significance of this shows that there were significance in prediction outputs in each model first. However, the Wilcoxon sign rank test tells us that there is no consistent differences in performance of species. And to validate this, we use the Friedman test, and then which confirms that there's the absences of pairwise superior. So there's no model agreements or just across each other, which was reinforced by the Kendall's W. And then which was highlighted by the performance gap because there was some improvement, but it was completely random. So and this was then again confirmed by stress testing results. That cut boost and XG boost and also light gradient boosting were approaching 1.0, which was a red flag. And this was confirmed by a known test in finance called White's reality check that stacking ensemble itself achieves the lowest observed loss. This is confirmed. This confirms it that this is indeed a red flag because it attributes to the randomness of the model, and which was likely overfitting or there was a leakage in the modeling stage. So for the causal style modern comparison, modern pairwise comparison, and this was the estimates exceed the magnitude of the effect itself. Like there was weak separation and then between state of the art models and the performance advantages may not generalize across the whole data set. So for my final recommendations, I would adopt multiple deep learning frameworks as much as possible. And then we should balance like accuracy and robustness in order to make it usable. And then we should explore more transformers or probably besides LSTM. And then we should use formal causal Bayesian networks, for example, and more causal studies. And yeah, the stacking while the stacking and geometric achieve the highest performance, it doesn't really prove robustness in itself. And I would really recommend to use logistic regression or the support vector classifier because it's more robust. And and this was highlighted by the eight based model comparison. And that's it. So I will now
Okay.
show the
Yeah, no, that's really good, Jorge. And you said you have a front end demo for this a little bit.
yeah, because my model when I was running it 5 minutes before, I the whole project crashed.
Okay.
Wait.
Can I ask a question, or you want to show the
Ah,
demo
yeah,
and then
sure.
we can go on? So
There is.
okay, yeah, you can continue with the demo first, and then we can, if we have time, we can go on with the Q&A.
While the whole program is loading,
Okay.
can I answer your question?
Yeah, so I see that you use like S&P 500 as the data set, right? Did you like
Yeah.
use a subset of it, or did you use like for a certain time period?
I use the for a certain time period. I use the 1999 to 2010 as the test training set, and then I use the 2011 and 2026 as the testing set itself,
Okay.
which might be exposing it to historical bias. That's what I was afraid of because
Mm-hmm.
because I needed to be cautious. Like I should have used like a 5 years validation set instead.
Mm-hmm. And so like if I would like, let's say if I'm a company, right, and I'm picking a model, like I'm going with your conclusion, right, which you mentioned, would my profits will increase or my risk will reduce? So which is the one thing which you targeted here?
I think majority of the companies should target or mitigate is their risk before the profit, since
Mm-hmm.
the model itself is just highlighting if the price is going to go up or going to go down. I didn't highlight if there was a strong buy or strong sell, and and I and I want to highlight that the model usage depends on the user's preference, since I stated I did put the option in the also stop.
Okay.
I did put the option that the user can choose the models on their own based on my conclusion.
Right. Okay. And can you also like explain that no free lunch theorem? What does it mean for you for your own project?
For me, since I've been doing machine learning for a very long time, no freelance theorem suggests that I use a various model because for example that in another project that some person just use XGBoost, right?
Mm-hmm.
And there's no way that XGBoost is the best model
Yeah.
in itself. And I want to say that you should have tested other models like logistic linear regression, for example, if it becomes good, even though it's not gonna become good, or use light gradient boosting model instead. Yeah, because it would be a good contender in itself.
Mhm. Yeah. Yeah, I think it's still loading for you, right?
Yeah, I'm so sorry, sir. It's
No,
just
no
not compatible
problem. Don't
with
worry
this.
about that. I totally get that. Uh,
Is it everything okay now, sir?
yeah, but I can't see anything right now. Can you share your screen again?
I oh yeah, I stopped sharing. Can I? Oh,
Yeah, please go ahead.
wait a second. I will leave it. I'll reshare.
Mm-hmm. So, Jorge, are you planning to publish a paper on this, or was it more for your like for academic work?
I am I'm I am planning to publish a paper for it.
Okay, yeah. Just wanted to know. Is your project
And
still
I
open?
wanted to get I'm sorry. I wanted to get your permission if I could get the company's backing on
Oh yeah, yeah, of course.
publishing this.
Definitely. Yeah, please go ahead. And if you want my help or Ali's help or anybody else's help, please feel free to add them on your paper. We totally fine with us. Okay. So if you need like my inputs, you can ask me to review it beforehand or things like that. So it's totally up to you.
Uh, oh, okay. Since right now it's not responding, can I get your feedback on the paper? Is
Sure.
that okay?
Yeah, yeah, that's fine. So you could just email it to me, and I'll provide you the feedback. Let me stop recording now. For now.